Hello and welcome to Math 8, Unit 4A, Lesson 4. Today's objective is scholars will understand and compare numbers written in scientific notation. Okay, so first of all, what is scientific notation? It is simply a way to write very, very big and very, very small numbers. It takes advantage of powers of 10. So, the rules are that the first number, this first number here, that was messy. This first number here has to be at least 1, but less than 10. And the second number is simply a power of 10. Notice this is 10 to the 7th power. So this is, you see 3, 2, and then I move my decimal place 7 times. 1, 2, 3, 4, 5, 6, 7. Each of those is filled with zeros. So, this is 32 million. This is 32 million. And then we have negative exponents. So the negative exponents are really, really small numbers. Positive exponents are large numbers. In this case, this would be, we would write the 7 and the 9, and then we have the decimal here. We're moving it 10 times the other way. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's my decimal, and each of these little bumps gets a 0. And this is just a really, really small number. So this is tenths, hundredths, thousandths, 10,000ths, 100,000s, millionths, 10 million, 100 million, billionths, 10 billions, 100 millions. So this is 7,900 millionths. It's a very, very, very small number. Okay, so what does it look like when we're on calculators? So different calculators display them different ways. But have you ever gotten something that looks like this? 8.3521 e negative 4. All that means is that it is 8.3521 times 10 to the negative 4th power. So that's how it's written. So they just use the e to mean exponent. So that would be 10 to the negative 4th power. Some calculators look like this over here. They give you a little times 10. And that's your second power. So that would be 7.88 times 10 to the second power. Here you can see 4.76 times 10 to the second power. So different calculators show them each differently. So now let's talk about how do we compare numbers that are written in scientific notation. So here I have 4 times 10 to the 4th or 4 times 10 to the 6th. And I want to know which number is greater. Okay, well, that's pretty easy. This, if I wrote it out, would be 4 with 4 zeros. This would be a 4 with 6 zeros. So which of these is bigger? This is 40,000. This is 4 billion. No, 4 million. 4 million. Obviously, if I have different exponents, the greater exponent is always larger. The greater exponent is always larger. If I have the same exponent, then I'm going to look at the coefficient here and whichever one is bigger. So how many times greater? If I don't know how many times greater, I'm saying how many times could I divide one into the other? Well, that's pretty easy. I've got 10 to the 4th. I have the same coefficient here. 10 to the 4th and 10 to the 6th. So it is 100 times greater, 10 to the second power. We're simply dividing. That's 10 to the second power. So that's 100 times greater than the other one. So let's look at these. Which is greater and how many times greater? So I've got 5 to the 8th or 5 to the 4th. So 5 to the 8th is greater because it's bigger, right? So that's greater. How many times greater? Well, it is 10 to the 8th divided by 10 to the 4th greater, which is simply 10 to the 4th power greater. Times greater. Okay, let's try another one. This next one, I have 2.7 times 10 to the second power or 2.7 times 10 to the 7th power. Well, the greater number is going to be 10 to the 7th power. That's obviously greater because it's a much bigger number. And again, if we do 10 to the 7th divided by 10 to the 2nd, I know that it is 10 to the 5th power greater. Okay, let's try one more. I have 8 to the negative 6 or 8 to the negative 3. Which of those is greater? Well, here's the thing. Negative 3 is greater than negative 6. Remember, we're talking about greater or less, so we're looking at a number line. Here's 0, 2, 3, 4, 5, 6. Here's negative 6. Here's negative 3. Further to the right means it is greater. Okay, so when you're looking at negatives, remember that. If I want to know how many times greater it is, again, I'm going to do 10 to the negative 3 divided by 10 to the negative 6. So negative 3 minus negative 6 is 10 to the third power. It is 10 to the third power greater. Okay? So let's look at this last one. Stars. The table shows the surface temperature of 5 stars. So you see we have Betelgeuse, Bellatrix, the Sun. Remember the Sun is a star. Aldebaran, and Regal. Which star has the highest surface temperature? So we are comparing these numbers. Which one is highest? Remember, highest is going to be our greatest temperature. Which one is highest? Which one has the greatest temperature? Well, we first compare the powers of 10. I see Betelgeuse and Aldebaran have 10 to the third power. So it can't be one of them. So it's got to be either Bellatrix, the Sun, or Regal. So remember, if we have the same exponent on our 10, which is 4 on each of them, we're looking for the biggest coefficient. So Bellatrix has the highest surface temperature. That's our answer for A. B says, which star has the lowest surface temperature? So now we're looking for the smallest number. So now we're going to look at either Aldebaran or Betelgeuse. Which one is smaller? They both have 10 to the third, but Betelgeuse has 6.2 and Aldebaran has 7.2. So Betelgeuse is lower. Okay, so go ahead and try these problems on your own, and I will see you in class.